All right, Mr. G Math, coming at you live from 7202. This is Lesson 6.2, Riemann Sums. In Lesson 5.6, you learn how to find signed areas using definite integrals. Not all such areas can be found this way, meaning not all such areas are easy squares, rectangles, triangles, trapezoids, and so on. Some functions cannot be integrated. They are said to be non-integratable. And sometimes you're given data or a graph, but not an actual function. It is still possible to approximate these areas. In this lesson, you will approximate integration by adding areas of rectangles. That is called a Riemann sum. Riemann is some mathematician that got credited for this method. All right, so what's the big picture here? We're going to integrate by graphing, and we're going to approximate the area under the curve by doing rectangles. Okay, so approximate, do you see the graph here? Approximate integrating from 0 to 10 by adding the areas of 5 rectangles, 1, 2, 3, 4, 5, and they're already drawn for you. So if I look here, and you can see a table of values where points are plotted and so on, so that can help us know what the dimensions are that we're looking at. So in this case, the first rectangle, what size is it? So if you look, it's 2 by 2. The next rectangle is 2 and by 5. The next one is 2 by 3. The next one is 2 by 1. And then the last one is 2 by 3. Yes, it's that easy. Relax. So what was the approximate answer to that definite integral by doing a Riemann sum? It's 28, if I did all that calculating. All right. In many cases, the rectangles used to approximate areas are of equal width. In such cases, you can use a formula to find the Riemann sum used to approximate the area. But the key is they have to all have the same width. So here, if you want to integrate doing that, if they all have the same width, you can actually factor out the width in front. That means all you have to do is add all the heights and multiply it times the width. Notice the number of heights will equal the number of rectangles. And to find the width of each one, you take the upper bound, subtract the lower bound, and divide by how many rectangles you have. That's simple. So let's look and see if we can do that. So approximate this integration by using 5 rectangles. That's what n equals. And an upper Riemann sum. So the heights of the rectangles are determined by the upper or largest y value in each interval. Sometimes it's called a right Riemann sum. That means it's the upper right corner, or what the height is. So if I'm going to do 5 rectangles, first of all, if I count across, I have 10. So the upper bound is 10, the lower bound is 0. 10 take away 0, divided by 5. Put that together. How wide is each rectangle then? So each rectangle is 2 wide. So I'm going to take 2, I'm going to draw all the way up till I hit the highest point in that area and to make my rectangle. At 4, I'm going to avoid this right one. I'm going to go up to the highest point in that rectangle. 6, again, I'm going to go up to the highest point in that rectangle, or the highest point for on the curve in that area. See, there's a point right there. 8, and then 10. You go up and then look at the whole area, make sure it covers the highest point in that area, and that makes your rectangle. So you can see 5 rectangles. The width is 2, and then you look at the height for each one. So the first height is 4. The next height is 5. The next height is 4 again. The next height is 2. And then the last height is 5. And there's your answer. So if we add this up and then multiply times 2, so 4 plus 5 plus 4 plus 2 plus 5, if I add this up, it's 20. And then 20 times 2, the answer is 40. And you just integrated and it's an approximate answer from 0 to 10. There you go. All right, turn the page. Now what we're going to do is we're going to create a lower Riemann sum, and it already tells you that n equals 5. Okay, so if I'm doing 5 rectangles, where number am I starting at? The lower bound is 0, the upper bound is 10, so 10 take away 0, divided by 5 for 5 rectangles. What's the width for each one then? It's 2. So I look from 0 to 2. What's the lowest point from 0 to 2? It's right there. It's at 0. So the first one actually is area of nothing. It's just going to be a line. There's no space there to even draw a rectangle. There's no area there. From 2 to 4, what's the lowest point from 2 to 4? And you can see it's right there. There's a rectangle, can find the area. From 4 to 6, what's the lowest point in that area? From 6 to 8, what's the lowest point? From 8 to 10, what's the lowest point? All right. And now we have the rectangles that we're going to find the areas of. So the width for each one is 2. The first height is 0. The next height goes up to 4. The next height goes up to 2. The next height goes up to 1. And the last height goes up to 2. If you simplified it, you would get 18. What we just did is we integrated from 0 to 10 of f at x. And the approximate answer of that is 18 by doing a Riemann sum, creating rectangles and adding the areas of each rectangle to approximate. All right, number 4. Approximate that using a right Riemann sum. Well, a right-hand Riemann sum, well, we'll talk about it in a second. How many rectangles are we doing? 10 rectangles. So again, we're going from 0 to 10. So upper bound subtract lower bound, 0 to 10. And we want 10 rectangles. So how wide will each rectangle be? 1. And it says a right-hand Riemann sum. So the right side of the triangle, from 0 to 1, the right end, you take the right end up to the graph and make a rectangle. 2, take the right end up and make a triangle. 3, the right end up to the graph and make a rectangle. 4, right end up, make a rectangle. And keep doing that all the way across. It's the right-hand Riemann sum. All right, now those are your rectangles. The width is 1 for each one. Just add up the heights. So it's 2, then 4, then 5, then 4, then 3, then 2, then 1, then 2, then 3, then 5. So all the heights going across. And if we simplified that, that would give you 31. So if I integrated from 0 to 10 of this function, the approximate answer using a Riemann sum is 31. And we're approximating using rectangles. Approximate using a midpoint Riemann sum, using 3 equal divisions. So my lower bound is 0, my upper bound is 6, and then you divide by how many rectangles you need. So the width of each one is going to be 2. So there's a rectangle, there's a rectangle, there's a rectangle. Midpoint means what's the middle of that rectangle? That's where I go up to. So I still make my rectangle, but I look at the middle and go, okay, the middle goes up to what point in the graph? And then I make my rectangle. Here, the middle is 3. So I make sure that when I make my rectangle, it goes up to that middle, which is 3. 5, go up, make a point. That's where you make your rectangle, through that point. Okay, so you can see I have my 3 rectangles I need to do. Now, find the area of an add up. Everyone has a width of 2. What are the heights? I don't want you to approximate that height. Instead, we have an equation to plug in. So what x value will I plug in? So notice that the first x value I'm going to plug in is 1. So I'm going 1 squared plus 10. That's 1 plus 10, which is root 11 is my first height. Then what x value am I going to plug in? 3. 3 squared is 9, plus 10 is root 19. And then the last middle one here, 5. So 5 squared is 25, plus 10 is 35. That's a good answer. And that is approximating what that is. All right, I drew over this. The lines bled through from the other side. I'm going to grab a fresh packet to do this one. So just wait a couple seconds. All right, I'm back. So let's look at 6-2 again. Let's look at that bottom one, example number 6, where the blue stuff isn't bleeding through. It said, it is possible that the function is not always greater than or equal to 0, and or that your subdivisions do not produce equal width rectangles. So you can still approximate the values. By doing that, you need to make sure and understand that below the x-axis is going to be a negative answer and above is going to be a positive answer. I'm not even going to draw the rectangles here. So it says separate the following using these x values. So first of all, I'm integrating from negative 10 to 5. Some interesting function, 2 to the x minus 8 dx. Because the x values that make my rectangles have different widths, I can't just use that formula where I can just put the width in front and then add the height. So each rectangle will be separate. So if I start at negative 10 and I go to negative 4, what's going to be the width of that rectangle from negative 10 to negative 4? So you can see the width is going to be 6. Then it says, what's going to be the rectangle? And it says use right hand. So right hand means at negative 4 do I need to find it. Now, I'm not going to approximate what it is at negative 4, and so I'm going to plug in it at negative 4. And the actual y value there will be negative. So I don't need to add or subtract. It's built in that that area is going to be negative. So I plug in negative 4. Okay, go to the next rectangle, from negative 4 to 0. Well, from negative 4 to 0, because there was my first rectangle. Here's my next one, negative 4 to 0. Again, the width is 4. What's the height? Well, I plug in the right value, which is 0. So it's 2 to the 0, subtract 8. Again, the answer is going to be negative. It's already built in, so I don't need to subtract. The next width goes from 0 to 2. 0 to 2, the width is 2. What's the right hand? So it's the 2, the right. So I plug in 2 for x. Some of these you could actually simplify easily, right? Some you could simplify not so easily. But you have the value. Again, for free response, you need to practice to just set it up correctly and let it go. If the arithmetic doesn't make it any prettier if you simplify it. And then the last one goes from 0 to 2. Oh, we have one that goes from 2 to 3. So if it just goes from 2 to 3, it's a little rectangle. The width is 1. Plug in 3 for x. And then the last one goes from 3 to 5. Now notice from 3 to 5, it's actually going to be above. Because finally it goes above. But again, it's built in whether it's going to be positive or negative. So the width is 2. And again, the right hand, the x value I plug in for the right is 5. That's it. All right, I want you to do the assignment and have questions for me, and we'll go through it.